Oh, there it is. Okay, I was starting to feel like someone stood me up for a date or something. I was getting weird flashbacks. I was getting weird flashbacks, let me tell you. Oh, it was so horrible. My God. So last time that we played, we were able to finally create some encased uranium cells and push ourselves closer to our goal of actually powering a nuclear power plant. And I gotta say, we are very, 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 very close now. I can really, really feel it. So today, I think we're going to be able to power this up for the very first time. If we look down to our left, you'll see that I have a much bigger building now. So if we head on down, you can see I've kind of organized some things so that this actually operates like a road, because previously all of these lanes that were feeding ingredients into our encased uranium cell building, they were all running along this path right here, so we couldn't actually walk on it. And now everything's been equalized. I've even utilized this really stubby little lift, which was kind of a difficult one to do. I had to figure that one out. That was interesting. I had to do some weird shenanigans, but now all of these are at the same level. Isn't that kind of crazy? So I think that looks really, really nice. And if we recall, when we head on inside, we've actually got some items that are passing on through that aren't even being used in this construction, and others that are actually being used and then actually pass through even further and then are fed over to the next building. Now, let's go in and take a look next door at our uranium fuel rod production. Now we have some copper ingots, some steel ingots, some overflow of deuterium ingots, all flowing in at different rates. On the side here, every once in a while, we're going to get, yep, that's right, the encased uranium cells. We're passing them and handing it over to the next building. We got the concrete flowing on in order to create some encased industrial pipe. And overall, this is the result. On the bottom floor, we have the creation of copper sheets here through 4 different constructors. We've got the creation of quick wire with 4 different constructors. They're then heading on down the road in order to process the steel ingots and the concrete so that we can make some steel pipes with the foundry with molded steel pipe that makes almost 50 per minute, which is almost what we need. And then some of those steel pipes are heading next door in order to create the encased industrial pipe so we can make some encased industrial beams. We've got 2 coming out at 2.25 each. Those encased industrial beams are then being passed upstairs along with some of the steel pipes, some of the copper sheets, and some of the quick wire itself. And then we've got a bunch of assemblers upstairs. This machine is creating all of our AI limiters at 7.5 per minute. We've got 2 machines which are creating stators, and then we're combining the stators and the AI limiters together to make electromagnetic control rods. Those electromagnetic control rods are being combined along with the encased uranium cells from the previous building, the encased industrial beams from down below, and the electromagnetic control rods right behind us in order to create 1.5 uranium fuel rods per minute between the 2 manufacturers. Those are then being combined and shoved out the other end so we can finally stick them into a nuclear power plant. So overall, I'm pretty excited about that. I know it's already built. At first I spent some time kind of just prepping it so that we could do it together, but then I realized I have a different project in mind that I think is going to be both very simple and very, well, not so simple. So I figured we'd take a look at that, but I left this open for right now just so you can see how it looks on the bottom. I actually really, really like it. A lot of it's off the ground, so we can kind of troubleshoot and just sort of walk around and do maintenance if need be. So I really like how this ended up. On the second floor, feeding the assemblers had to be a little more creative. We had to operate on different levels to make sure that all of these things are able to flow without clipping. And I just feel like when I open this up, it really looks like stuff's happening. You know what I mean? So I really, really dig it, and I'm so glad that we've got all the colors and the Mark 6 belts. They just look phenomenal. I'm just really, really, really happy with that. So this is the final product right here, the uranium fuel rods that are coming out from both the manufacturers being combined together and then shoved out the opposite end. Now, I'm actually doing something that I didn't think I would do. I found out you can sink them out in an awesome sink, but I'm actually collecting uranium fuel rods right here. Why am I doing that? Now, we're going to be powering 3 nuclear power plants, and each of those nuclear power plants is going to take 0.5 of a uranium fuel rod per minute. And unfortunately, we only have 2 manufacturers. Those 2 manufacturers are only pumping out 2 uranium fuel rods per cycle, or when they go through 1 cycle of creation. And the problem is you can't really break them in half and stick some piece of it into a nuclear power plant. So I figure we kind of have to have, they're going at the right rate, but we kind of have to have a little bit of, I suppose, like backup prepped and ready for these guys. Or we put in another manufacturer, which we might have to do. But that's for another time. I just want to see one of these things actually power up and see how that goes. So there's a couple of things that we need before we can actually insert a uranium fuel rod in one of these nuclear power plants and have it go. So if I actually put down a nuclear power plant a little bit closer so that we can kind of visualize how this is going to flow, I'll just throw one down right here. The nuclear power plant's going to take in uranium fuel rods, and then it's also going to need to take in some water. So if we look at the input right here, we have a slot for the uranium fuel rods, and then we've got a slot for water. Now, as I understand it, when we actually overclock this all the way to 250%, we're actually going to need to pull in like 600 cubic meters of water. You can see the consumption down below on the lower left-hand corner. I think that updates, yeah. Now, the normal thing to do is to get a water extractor. So we'll go production, we'll go water extractor, we toss that in. And then if you take one of the water extractors and you just pump out as much water as possible, it puts out 300 cubic meters. So you can get 2 of these things, merge it together in a Mark II pipe, and shove it in there. That's super simple, right? Now, I'm not trying to make things more complicated for myself, but not on purpose anyway. But I thought it would be so cool if we added more drones to the mix. We've got 60 drones right here. We might need more, who knows? But I think it would be really, really cool if we actually took... Oh my god, I realized there's constellations in the sky. Sorry, I'm very easily distracted. So what I was thinking is we could have a tower, and in the tower are a bunch of packagers at the top with a drone port, and we can actually feed water via drone and have the water fall down via a pipe and then come on into here. And I think that would be really cool. So we actually have a site where we can make that happen. I just haven't had a receptacle or a destination for that water because I want to have a closed loop with all of the empty canisters. So I think this is now a good time to at least test it out. Is this going to be a final setup? No, because I'm probably going to want to make sure that I'm not too sure how we're going to place the nuclear power plant first, whether it's on a raise, whether it's on top of the building, you know, wherever it is. But I do want to see what happens when we do this and then we add some water to it. It's just a matter of how are we going to do the water. So the first thing that I think we should do is understand how many packagers is it going to take to feed one of these things. So I'm going to go over to production, and then we're going to go over to packager right here, because we're going to have to unpack water. Now, I think for oil, it came out at 60, I think it was like 60 cubic meters per minute. This is going to come out at 120 cubic meters per minute. If I were to overclock a packager, it can max out at exactly 300 cubic meters per minute. Well, that works out very nicely, because if we were to overclock them, how efficient is that? Because obviously every time we power something and then overclock it, it uses exponentially more than normal, right? Either we take this and it's 120 normally, right? If I were to take 600 and divide it by 120, there would be exactly 5 of these things. So without overclocking them, and since we are trying to create power, maybe it makes sense to have 5 of these things. And then between the 5 of them, we'll go ahead and merge all 5 pipes down into one, and one's going to feed the thing. Now, although now that I'm thinking about it, you got to think downrange, right? So when we're looking at all our nuclear power plants, we have 3 for the uranium stage, we've got 8 for the plutonium stage, and then we've got, I think it was 4, I don't remember, for the fixonium stage. It's way down on the end there. So if we take that and multiply by 5, that's a lot of packagers. That's like a lot of packagers. Let's go over to our packaging water site, and we're going to figure out what it is that we need to do how much water do we need to pack, etc. Well, I guess we probably got to start with the number of nuclear power plants. That's going to tell us how much water we've got to move, right? So in the distance, I see 1, 2, 3 for this stage, 1, 2, 3, 4, 5, 6, 7, 8 for the next, and then 4 for the last. So that's going to be 12 plus 3, 15. That's 15 total, and that's 15 times 600. That's 9,000. We're going to need 9,000 cubic meters of water. Okay, well, that's good to know. So we're going to head over to our other site. And now I present to you our water packaging site. That's right. We're right next to a waterfall. What better place to package water than next to our own Niagara, right? Not too shabby. So if you're wondering where we are, we're way up here in the north. And this is our... Oh my god, wow, that looks crazy. This is our nuclear power plant site? Actually, no, I don't think it is. I think this is our... Yeah, okay, this is our nuclear power plant site. Oh, that was a little awkward. I was like, oh my gosh, what happened? We're building in the negative or something. I don't know what that is. I guess I just haven't really been out there. But we are out here, and we're building our nuclear power plant site right here. So not too far away, but this is where I figured we'd have the most open water. That's kind of close by-ish in a very nice and picturesque location. And we've already kind of routed a beginner platform with some water extractors, right? So let's go in and see what it takes in order to package, let's say, 600 cubic meters of water. So if we go to our packagers and we take a look at packaging water, it comes in at 60 cubic meters per minute. Now, if we were to overclock them, that allows us to go to 150 cubic meters per minute. I almost feel like we should just take one away and do the 120 cubic meters per minute, because we know that it's going to take 5 of these things to do 600 cubic meters per minute. So if I think about that, if I go like this, 2, 3, 4, and 5, and then I copy these all the way through, and let's say just for illustrative purposes, we color those up, then right now we've got 5 water packagers at 120 cubic meters per minute, each all in total pumping out 600 cubic meters per minute. So this is going to power one of the nuclear power plants. So with that in mind, 5 and we've got 15, we're going to need 75 partially overclocked packagers. Oh man. All right. Well, maybe the easier thing to do, now that I think about it, is to come up to the... Either we come up to the full 150, because 60 would be ludicrous. Because think about that. Let's say we took 9,000. That's how many cubic meters of water that we need for the entire plant by the end of it. And we divide that by 60, which is... We're going to need 150. We're going to need 150 packagers. Wow. So that would be... That's a lot. Since I'm doing this just for fun, I'm not really doing it for the power. I feel like I'm going to do some overclocking. I'm probably going to overclock all the water extractors to 300 cubic meters per minute, but you get an idea if you didn't, right? Obviously, it's going to draw more power, so we're going to get a net positive of... Hopefully a net positive. We're going to get less power out of the process, and then I'm going to overclock these probably to... Well, if I did 150... then it's going to be 2 water packagers each, right? So I just copy and paste, and I would clear these 3. And so essentially, this is what it would look like. We would have a fully overclocked water extractor at 300 cubic meters, and then we'd have 2 fully overclocked packagers handling it for that single water extractor. And then in order to do this for one nuclear power plant, we're going to need 2 fully overclocked water extractors and 4 fully overclocked packagers in order to handle one nuclear power plant. And then that's 4 times 15, and now we're at 60. That seems a little more doable. But you know what? Let's not be afraid to go big. Either way, this is just a test. Let's start out with... We're just doing it for one nuclear power plant. I will fully overclock the water extractors because I do not enjoy making tons of these things. And Then after that, I'm going to go ahead and have water packagers like so. And 2. And if I were to fully overclock these, so I'm going to package water, fully overclock it. That's 150 cubic meters per water per. Yep, so a total of 300 cubic meters of packaging. Then I can take this one and then, yep, at 300 cubic meters and then basically split it like that. So let's bring this up. We're going to switch over to horizontal to vertical. And we're going to come up. Ooh, I guess that's too much. Is that too much? Maybe we'll switch it to auto. There we go. So we'll just bring this across. And then stick a pipeline junction on it. Cut this off here. And then reattach. And then we'll have it come out to the side. I think I'm going to avoid trying to have... Well, I do want it to be kind of flat. I guess it's pumping up and then coming down, so that's a little more efficient. It's a little bit weird. I don't know if I'm going to go with that exact look, because it's definitely gooey. There aren't as many right angles as I normally would enjoy, but it's all right. This is just a test, right? So let's go ahead and just get temporary power hooked up. We'll go ahead and hook in a power pole like this. And then we will power up both of these things like that. And then we would need to pass in, well, the water, which it is receiving now. And then we would need to pass in the empty canisters. Now, the empty canisters are only a temporary thing, meaning I can actually bin feed them, because we're going to be receiving those empty canisters right on back when it comes to the drone system. Because as we are passing them into the nuclear power plants, when the empty canisters from unpackaging the water are dumped out, then the drone's going to be taking them right back here. So that's going to be just fine, I think. So let's go ahead and just put in the splitter so that the empty canisters are passing on through. And then we'll just connect them up to the machines like so. And then I'm just going to go ahead and grab some empty canisters, which are being created over in the Dune Desert. We'll get 500 and we'll slam them in. And there we go. So now water's being packaged just like that at 300 cubic meters per minute. It's actually kind of mesmerizing. Maybe just for illustrative purposes and for my own gratification, I'm just going to go ahead and color these up. And then out, this all comes all packaged up, and we're going to get a drone port. So let's just get a drone port in the meantime and kind of do that. We want outcoming is just solids, so we'll get a merger. We'll just send that right in. And we will get some temp power to let that flow in, and there they go. So that's going to be flowing in at 300 cubic meters per minute. And we're going to need to do that with maybe like another one of these in order to keep up with a nuclear power plant, right? Because we want to do a test with a singleton. And they're both going at 150 cubic meters each for a total of 300. And then we'll just duplicate this. And then I'm just going to pass this down the lane and stick the splitters on it so that they also get containers. And there we go. Perfect. Although I guess I ran out of containers. So there is some level of, you know, however many containers you do need, but that's going to flow on through, and now that's stacking up. That's perfect. So I just need to make sure that I'm providing enough power. I probably should have just used a higher mark power pole, but right now that's at least getting us started. And then we'll just merge down the lane just like this. That's a little bit close. There we go. There it is. And this is facing the wrong way. Okay. All right, perfect. And then obviously I'm going to need more empty canisters like crazy because it's going to burn through empty canisters like you've never seen. So let's go ahead and do that. And then now, this should be coming in at 600 cubic meters per minute. There it is. Perfect. And just to double check, we have, well, it's a 61% efficiency, but I think as long as we've got canisters, it should be able to maintain this pretty easily. This is a relatively simple setup. There we go. It's at 100. Now let's just... Oh, we ran out of canisters already. See the big problem? I'm seeing a problem here. I'm seeing a bit of a problem here is I don't have enough canisters available. Well, I can change that. You know, the easiest thing to do is just go to the source and have enough canisters. Right now, how are we packed up? I mean, that's going to back up soon enough. Tell you what, let's go in and reprogram one of the portals so that it can actually take us over to one of the sources where we're creating empty canisters, right? So I'm actually going to choose our power lagoon, and I'm just going to relink it in the meantime. So I'm going to say I want to go to this satellite portal right here. That's the one I want to go to. Yeah. So we're going to retool it, and in 30 seconds, it's really, really cool. We can actually just have it hooked up to a different location entirely. My plan is just go in, grab a bunch of containers, and in full industrial storage container, toss it in, and that should at least get enough in the loop, get it saturated to get us started, and then we can see whether this is going to work or not. Because I just want to understand that, yes, this is possible. I'm pretty sure the answer is yes, but you never know until you try it, right? So this is where we are making all of our empty canisters, and also where I have been trying to wait for the dimensional storage to catch up. And instead of just adding more dimensional storage, because it's very rare that I need to just grab empty canisters ad hoc, I figured I'd just come to the source, right? So here it is. We'll go in and just grab all of that, and let's get a move on. So we're heading on back. We've got a ton of empty canisters, and now we're just going to head over here and toss these all in, and they're going to fly at least for a time, right? Eventually it's going to run out, but at least for the moment, it will not. And this is going to fill up, and everything's going to be hunky-dory. That's great. So what I'm going to do is just get another... Well, actually, I don't even need to. What I can do is just get a container for this as well. And I'm going to feed it some fuel, right? The fuel, I'm fortunate enough that the packaged rocket fuel burns slowly. So this should be sufficient for one drone for testing purposes, right? So we can go drone. We're going to tool it up for water. And this is going to be our water drone. Yeah. So right now the water drone is picking up water, and we are saturating this drone port. That's great. I'll just say water work site, water, 600 per minute delivery drone, right? So we'll just do something like that for now. There we go. So that way we can recognize it on the network. All right. So now we have arrived at our nuclear power work site. There she is. God, it looks so much better than it did before. It actually looks like it has a purpose. It's coming in hard with a purpose. So there is our proverbial nuclear power plant. I'm going to go ahead and just hook it up to some type of network right here. And it is now part of our grid momentarily, right? It has no fuel. It needs fuel and water. And it's currently set to consume 600 cubic meters per minute. So what we're going to need to do is build some kind of tower first, right? So let's go ahead and get some walls. I'm just going to get basic walls. We're going to make that come on up as a start. And I suppose since it's just a drone port, at first I was thinking, oh, right, we need unpackaging as well. That's right. I totally forgot that we need unpackaging as well. And I'm running out of power, which is a little annoying. So I'm going to go and grab this, bring this over, and now we're good. Okay, perfect. So we're just going to go ahead and get our 1 meter, bring this over. And to unpackage all this stuff, we determined that 2 fully overclocked packagers should be enough to unpackage the water that we are receiving at a rate that is at the necessary rate, right? So let's see if we get a packager up here and we go unpackage water. It's at 120 cubic meters per minute. We would need 5 of them. Now, if we get one of these, it can go up to 100. Oh, 180. If we get 2 of these, then it's going to be 240. I mean, I guess we can do 5 for the test, but God, this wall is going to be large. Then again, what isn't large? There's a reason why nobody really does this, right? Then again, I don't know. Does anyone really do this? We're going to need 5 of these things for 1 nuclear power plant. And I just have it up here so that we can simulate the elevation, not that it's going to be this high. And then I'm going to need a place for the drone port, right? And I realized that I only have 1 delivery drone. Honestly, it should just be a pickup point because I'm probably going to need multiple drones per, right? And this is what I'm talking about. I'm going to have 5 of these things. So unpackage water, and then we'll just copy that. We'll paste it. 2, 3, and 4. And that makes 5 total. I realized I didn't count that really appropriately. And we'll go 1, 2, 3, 4, and 5. Perfect. So that's all to unpackage water at 120 cubic meters per minute. Now what's coming out is just empty canister and the water. Okay. So let's go ahead and have another lane right here. We're probably going to need 2 delivery drones, I would imagine. So we'll go drone port. Well, I guess we could have singular receiving ports and we're going to have multiple ones coming in. Maybe that's better. Okay, this is all on the fly. I'm trying to figure this out as we go, so I apologize if it's kind of all over the place. But this is what I'm thinking, right? So we're going to have these tall towers. We're going to have a bunch of drones coming in. And I tend to think that I like the idea of having drones queued up and waiting and then trying to saturate 1 drone port. I like to have many drones going to 1 drone port and dumping stuff off. I find that I can kind of account for that consistency of flow more easily than if I had multiple drone ports and each one's going to their own drone port as they want and they're landing and then we're merging everything together. I feel like it could be a little bit cleaner if we have many delivery drones coming down this way as opposed to the other way around where we've got pickup drones going to a pickup point and then picking stuff up. I feel like out there, they're already coming from a loaded place and then they'll be able to come to 1 place and then we'll have 1 output, which I think is going to, I don't know, it just feels more consistent to me whether that's actually the case or not, right? So what do we have coming out? We're going to have packaged water coming out, just solids, and this is going to take that packaged water, which are just solids. That's it. So let's go ahead and do just the splitter thing. We'll have it receive from this point. This is probably the easiest way that I can think to do it, at least for our test. And then we will just run a single line down the lane. So it's going to come out that way. Well, maybe more like this. There we go. There it is. So it's going to just manifold feed all of these things with packaged water. That's how that's going to work. There it is. So we're going to take in all the packaged water at this location. Let's just go ahead and name it. This is test water. I like to think of it like a bunch of Dixie cups. Dixie cup test. How about that? There we go. So all the water is going to come into this 1 port and then come out here where it's going to unpackage like crazy. I guess to make this easier on myself, I'll get 1 power pole Mark III. We'll just kind of connect everything to this 1 power pole like that. And then we just need to connect this to any source of power like this. There we go. And now all these things have power. And then coming out, we need to merge 5 of these. See, this is the part where I'm thinking maybe this might be a little unwieldy and why I'm tempted to reduce the number of machines on this end, because we're going to have to merge 5 packagers into 1. And these are going to need to be Mark II, I believe, because we need to move 600 per minute through 1 entry port on this nuclear power plant. So that's how that's going to work. So we do need to merge them together. I don't really have a choice. And then the empty canister's got to come back and then flow back into the drone port. So that has to happen. Okay, so let's go ahead and merge to the left. And we're going to merge them together. And then that merged set of canisters is going to enter back into the port. So that's the idea, right? And then when it comes... Oh, that's clip in there, but it's just a test. And then when it comes to all of our pipes, I suppose we can come off of maybe the middle one. That probably makes the most sense. There they are. Should all be identical. Perfect. And then we're going to get our pipeline junctions, and we're just going to slam them on. Right on top of each of our mergers. So let's get these all attached to the merged set of pipes. Excellent. There we go. So you can see it. All the water is being unpacked. It's then being merged together. And, oh, you know what? I forgot Mark II pipes, because it's got to be 600 cubic meters per minute. Now, normally I would think I only need this part to be Mark II, but I don't want any sort of flow issues. So I'm going to go ahead and replace all of them as Mark II. So there are no Mark Is here. Yep, that looks about right. And then they're going to come on down and then go into our nuclear power plant. Tell you what if we go like, can I start from down here? And go like this. And then since it's horizontal to vertical, it should be relatively straight. That works pretty nicely. Look at that. And then you know the water's coming from above, right? Oh my god. Yeah, that doesn't look fancy. Okay, perfect. So for this test, I think we've got our destination now. So all we got to do is send the drone over. I have a feeling it's not going to move enough water quickly enough. So let's at least test and see what the throughput is like. I'm not going to give the nuclear power plant the other part of the equation, which are the uranium fuel rods, until we can verify that this is coming in at 600 cubic meters per minute. I have a feeling I'm going to need another drone. I almost guarantee it, but we might as well just go for it. So I'm going to say all ports, waterworks site, and we're going to say come to this port right here. So that thing is cruising on over, and it's going to drop off some packaged water, and then we'll see what kind of throughput that we get out of it. Oh, there it is. Okay, I was starting to feel like someone stood me up for a date or something. I was getting weird flashbacks. I was getting weird flashbacks, let me tell you. Oh, it was so horrible. My god. Okay, so here we go. So very first load, one drone to one drone port right now. And we're just going to take a quick snapshot of the throughput. There it goes. And that is now unpacking, and the water's going to saturate down below. Look at that. She's filling up 120 cubic meters per minute, and there go the canisters. Look at that. So that means that thing's going to be picking up canisters as well, right? So the question is, are we going to run out? I am almost guaranteeing we're going to run out of water right here. This is the real kicker. Yep, as you can see, we're going to run out of packaged water before that drone comes back. And we always need to have packaged water in here. Now, obviously, I could have a bit of a bank right here with like a storage bin or something like that. But honestly, the storage bin of this should be sufficient. So we're going to have to add another drone to the system. Already this is saturated, so in theory, I could plug in the uranium fuel rod and that'll run for a little bit. Let's add two more. So we're going to add two more drone ports, but I'm only going to activate one at a time, and we'll see what is sufficient. I think since all of our, I guess, water towers in the future are going to get closer and closer in that direction, we're actually going to need either the same number or fewer drone ports assigned to send over water in the future. But at the same time, I don't know if... You never know until you try, basically. Okay, so we're going to get our drone ports. We probably need to open up that container right there. Make more room. And we're going to go 1, and we're going to go 2. But I need a little bit more room. And then we're just going to power or color all these up. Add the drones to it. And then this is waterworks site, but we'll call it drone 1. It's going to be drone 2. And then here, this is going to be drone 3. And then we need to distribute this product across all 3 now. So let's go with... the output is tight to the chest like this. We'll get our merger, and we're going to merge off this way down the lane, and then we'll split her out. Like that. And we'll fill all of them up, right? We'll fill all of them up. So now I'll just add 1 Mark III pole. We'll attach the new drone ports to it, and then we'll attach this to the system. So now those are getting what they need. We're going to also need to return the fuel canisters, the empty canisters. So we're going to have to merge those down the lane. And that's how we're returning the empty canisters into the loop. So it's one big loop, right? So right now we still have empty canisters, but those haven't been returned as far as I can tell. These are outgoing. These are incoming. These are... do we have any outgoing? I see. They're actually going... aha. They're actually loading into the drone. That's why. They're loading straight into the drone. There it is. And then we just need a way to distribute the fuel. So I'm just going to not worry about clipping. So close your eyes. Close your eyes, bunnies. Close your eyes. It's going to be fine. Don't worry about it. There it is. I know. The horror. It's horrible. Nobody needs to see this. It's just a test. I feel like it's those emergency warning systems where you have like a radio or TV going gong, or whatever. It sounds like an old modem. And then they tell you it's the emergency broadcast system. It's really a unique sound, so I guess it makes sense why they would use that, but I don't know, it seems a little weird to me. Here we go. All right, we'll add package rocket fuel. Perfect. I'll take one for myself and then toss that in. There he is. Okay, great. So right now everything has fuel. That's fantastic. We suspend our marriage to realism, and we've got these weird clipping going on. All the water is being distributed passed into the outgoing sector for all 3 of these drone ports. We've got drone port 1, 2, and 3. And currently we've got an output of 133. This actually tells us a little bit about what's happening, right? So 133 items per minute. Ooh, we may need even more drones. This is not good. This is not good at all, at all. Have we even returned with any empty canisters? Maybe we have. Okay, well, let me just... oh my god, that's a lot of canisters that we have going in rotation. This is a huge project. Holy crap, what have I gotten myself into? Okay, it's fine. Don't worry about it. Don't worry about it. Just because I'm getting worried right now doesn't mean that I'm going to worry about it. Well, let's get back over, and I don't know if 3 drones is going to be enough. I'm not sure if 3 drones is going to be enough. That has me a little bit worried, actually. Glad we're doing this in a test and not full scale. It's a little difficult to understand until we do something like this. Any sort of planning is just out the window because you don't even know if what you got set up is going to work or not, right? At least it's simpler looking on this end. We only have 1 receiving drone port, so that's a plus. Okay, so now I understand. Right now, because this pipe is clogged, he can't really drop off more. It's saturated. He should be getting the empty canisters that had been removed, though, so that's a plus. So I guess all that we can do is actually insert a uranium fuel rod, and we're going to see this thing working for the very first time. Right now, we've got a few stacks of the stuff, and let's make it happen. Here we go, bunnies. You ready? Oh my god, I can't believe it. There they are. They kind of look like lanterns. Uranium-filled lanterns. Oh my god, look at that. Wow. Oh my god, one of these things going to turn on for the first time. Let's chrome it up. Let's chrome it up. Oh my god. This is a big moment for me. Obviously, we're going to have nuclear waste. Oh, crap. See, I can't keep this going for too long because there's going to be uranium waste. So we're going to have our very first unsinkable uranium waste I'm not going to be able to do too much with. So let's just have that there. And what do we got? Oh my god, it's happening. I really want to see this, but I'm also worried about... Oh, it's happening. It's coming out. Ooh, it's coming out. Oh, yep. It's building up. All right. Uranium waste is building up. This is no bueno. But we are getting 6250 megawatt right now. That's great. Holy moly. And apparently it's doing stuff. I think. What's happening on this side? Is it cool? God, it seems so docile. I mean, I see all the steam or whatever coming out the top. It seems so docile. Wow. I'm curious if you do like plutonium and fixonium, if this changes inside colors or something. Well, there it is. You got nuclear uranium waste coming out at 25 per minute. Okay. 25 per minute. That makes sense because I calculated for 75 per minute. We've got 3 of these things. That's great. That's great. Okay, good. And it's going to be half of a uranium fuel rod per minute. That's great because I calculated 1.5. We got 3 of these things. So what's the throughput here? How are we doing up here? I guess one thing that I could do is just see, will the drone come back before the water is out? If that makes sense. That's going to be my test, I think, because I've just got to wait for one cycle of that drone to pass by and then come back. And I do not want us to be out of water. Was that it? Is that what happened? Oh, there it is. Oh my God. Come on, buddy. Come on, buddy. Just handle it. I mean, at the very minimum. Okay, there it is. It did it. It did it. Did it pick these up? It did. Look at that. It picked it up. Okay, perfect. So it seems like it can do it. But I would feel a lot more comfortable if we had 2, you know what I mean? Just so that it has some overlap and redundancy, because I feel like it's a little too close for me, if I'm perfectly honest. So that means 1 drone port per water extractor, if that's the case. So if I say water, and I want to pull from Mr. Drone number 2 and come here, right now that's drone number 1 and drone number 2, right? So now they're going to be sharing the load. So we've got 2 water extractors overclocked at 300 cubic meters per minute, feeding the 3 drone ports off at the waterworks site. And right now I've assigned the 2nd drone port to come on over here. So now we've got 2 drones. I'm not touching the 3rd. It looked like the drone kind of came from below for a moment. So yeah, look at that. That's weird. That is a weird landing angle, but sure. Maybe it's because it's towards the end of the map. So I don't know which drone this is, drone number 1 or 2. And if we back out, we might see the 2nd one. I want them stacked and waiting. I want them either like in motion. Oh my God, we're building up uranium waste. Horrible. I don't like it. That's why this is important. We got to make this, we got to take advantage of this time, our testing time. And I want to see someone vulture, you know, spinning up there at some point. Where's our backup? Come on, guy. We need you badly. We need you badly. Wow, maybe we do need 3. Where is that 2nd guy? I can't believe it's taken him that long. Is that right? I'd have to turn on drones, and oh my God. There says there is a drone coming on in, but we are now empty again. We're empty again, and we are full here. I'm actually going to clear out some of these empty canisters because it's a bit of a balancing act, right? Where'd he go? There he is. All right, so he's depositing. Where's the next one? Do I see one coming way out here already? I'm assuming if there's a drone here, is he going to stop out there? Oh, he's just landing now. So is this guy taking off when he's landing? We might need 3. Oh no. Wow, that's going to be a lot. 3 per 2 water extractors. Yeah, I have a feeling we're going to need 3. You know what I mean? I mean, because let's take a look at the map, right? This guy hasn't taken off yet, and our guy's taken off already, and we're already running out of water. Okay, so I might have to go up to 3. If I think about our setup over here, I needed like 6 drones for long distances. I was kind of hoping that it wouldn't be this dicey. Well, let's add the 3rd and see what happens. This is what testing's for, right? That has just been assigned. It's just been powered up. which means we're gonna have a weird situation here where we're gonna have 2 taken off. So one's taken off. This one's powering up right now. It's a strange path that they take. They go along the edge of the map. They don't go straight over. You see that? Maybe it's because of the elevation right here. That's an odd one. Well, that's Caterium Ingot. That's our guy. That's our guy, and that's our guy. It's these 3 right here, I'm pretty sure. Yeah, look at that path. That's weird. 393 items per minute. Look, there we go. There we go. It's actually circling. That's what I want to see. I want to see that right there. So this water's coming out. He's dumping them out. He's picking up containers. That's a good sign. And we actually have drone number 3 queued and circling, although kind of strange that it's circling underneath. And now the nuclear power plant has picked up again because it's actually getting water. So that one's going to take off, and then this one's going to land, and right in time because we're about to run out, right? So this guy is going morphing through the bottom. When we ran out, wow, interesting. So even though we were queued up and vultures circling, this next one's already circling. Look at that. The question is, how large? 1, 2, 3, 4, 5. Yeah, this guy had a full stack because he's drone number 3. He was already sitting there, so he already fully saturated. So this is drone number 3 stacked. He's got to get out of there. You got to clear out of the way, buddy. If they're not clearing out of the way fast enough, I'm going to need a second port. All right, so this guy's coming in, but there's that animation in the handoff, and that animation may be too long, where 9 stacks of water being consumed by all those packagers. That's tight. That is tight, because even though he's technically in position, he's got to descend, that door's got to open, and he's got to place the package in. And there it is. Time up. Time up. He had to have dumped off his set of 9. I can double check if he's got 9, which means these 2 rows should be filled with package water, plus a little visual element down here, and that'll be a full stack of... Yep. So we did have a full stack of 9, so that's a plus. So they're able to keep up the rate. It's just the animation itself in the handoff is too long. It's too long. So I will definitely need to have 2 ports, which I'm curious if I can run 1 and 1. See? Oh man, this is getting complicated. He's going to do his last drop off. He was in the middle of it. And then I'm going to make it receiving number 2 like this. There it is. Okay, perfect. And I suppose I'll just add in the empty canisters here just because, and we'll split them. How about that? Yeah, they already seem like they're split. That's perfect. Okay, so now's the moment, right? I'm going to go ahead. I'm going to get our ports assigned. I'm going to do 1 and 1. So 1 to 1. So just 2 drones this time. So we're going to go with drone number 1 to this port. Then the other one, we're going to go with drone number 2 to this port right here. It seems to be in transit already. Really? Please don't be in transit. Oh, it's going back to its position. Oh, crap. Okay, well, then that means it's not ready yet. So I need to actually take drone number 3 instead, because the one that we had here was drone number 2. So I'm going to say no port. I'm going to say this one, this port. There we go. Excellent. So in theory, for this port, we only have 1 water drone, more importantly. And for this port, we only have 1 water drone. So it's 1 to 1 right now. And they're going to be delivering and picking up all of the canisters. So first one's dropping off. And ideally, this is going to allow them to just move as quickly as they can without having to wait for another drone. Because they have their animation, we have to account for that. We just need these ports not to really run out, right? 1 drop off. There it is. And it's a full stack of 9. And he was able to empty out the outgoing canisters. We have another one here. He's going to empty this out. Come on. 50. And there is the 8. There's a drop off and the pickup. Perfect. So I think that actually emptied out all the canisters as well. Wow. Okay, that's great. So they're splitting the load. They're doing a good job. Right now, we still have water coming out of here. That's great. Okay, this is looking a lot better already. I mean, obviously, they were fully stacked and waiting, but now let's see if they can keep up, right? This is... Oh, no, not yet. Not yet. He's still receiving, still picking up, right? Yeah, look at this guy. And there's 2 here and 3. So, oh boy, we gonna last? Oh, all 3 of them are chilling. Not what I like to see. Come on. I need you moving. Oh my god, can you imagine if we need 4 drones, 2 per port? Oh boy. It's okay, don't worry, don't worry. This is gonna work. It's gonna work. All right, one's moving. That's what I like to see. Can it make it in time? That's the question. Because it's going to this destination right here. Oh, we're running out. We're running out. And we are dry. But the second one is covering. The second one is dry. Okay, we've just gone dry. We've just gone dry. Come on, guy. Where are we at? He's coming. He's almost here, but it's not fast enough. Are we running out? We're not running out yet. We're not running out yet. We didn't run out. Something's telling me that I need 4 drone ports, 2 receiving on this end and 4 on that end. 2 drone ports per water extractor. Oh my god. I mean, in theory, we could activate the 3rd one and go 3 to 2. We could always try that. Well, let's get drone number 2. So if I say this port, so we've got 2 drones going to port number 1, and then we've got 1 drone going to port number 2. There's the actual third drone. So we got drone number 1, drone number 2, drone number 3. All right, so we've got the other drone coming in right now. We've got all 3 drones on site right now. There they are. So here comes the water. How low did we get? That's 40, that's 20, that's 5. Yeah, that is not good. All right, let's see if this corrects the issue, right? This guy hasn't even arrived at his destination yet, and we're already going to need someone coming back, right? So back at our drone system, we have 6 drones per material. Something tells me we're going to end up with 6 drones coming in here. Oh boy. Yeah, something tells me it's going to be 6 drones per nuclear power plant, which is 90 drones for our nuclear power plants to drop off Dixie cups of water. Because right now we're starting to run dry. Unless that first drone's already taken off, which he has not yet. There's number 3, there's number 1, there's number 2. We're in trouble because we're going to run dry. So I think that has kind of answered my question right now. If we want to do this, we're going to need 6 drones. Not even joking. We're going to need 6 drones. I'm going to pause this right now. It does say that we were at 100% efficiency. Okay, we're going to do one more test. We're going to do one more test. And yeah, let's see how this goes. And up, there it is. That is, look at that. They fly on down and go back up. That's actually kind of cool. So that means if we look at them now, we've got 435, we've got 228, we have 175, 270, and I don't know where the other 2 drones went. I'm assuming that means that they're still over there. Is that right? So I can already see some of the drones out there. They shouldn't be right there. I told them you have no port, so I was kind of hoping they'd come back. I might need to unstuck them, because if they're stuck there, they're going to stop the other ports from landing, or the other drones from landing, and that would just be a real travesty, right? Is this because it's backed up and he can't deliver the goods? It does look like it's backed up. Let me go ahead and pull out some of the water. That's going to allow him to make his delivery. This is also backed up. So I'm going to turn this back on right here. It's going to start to process the water. And that's going to allow these things to go again. They're out now. I want port number 1 to come here. I want port number 2 to come here. And I want port number 3 to come here. And then I'm going to have the pink ones go here. Port number 4 to come here. 5 and 6, there they are. So they've all been assigned. They're doing their thing. I'm gonna put some incoming water here as a stack. I'm gonna do the same right here. And off they go. So this one's just chilling because it can't make its delivery while this one still has water flowing in. So right now, it's a little bit, the test's a little bit off, but once it starts to get saturated, it should be fine. So how are the drones doing? I mean, they got plenty of time. Look at that. Drone 1, 2, 3, 4, 5, and we've got the 6th one here. So all 5 are in transit. This guy's still doing his thing because he's waiting. I feel like I should probably clear this off so that he can actually drop out his water. Just help him get moving here. And I'll stack that in there. I mean, I would imagine that all the drones do not have full loads, right? All right. Now that the drone's clearing out, we can check the actual rate, right? Here they come. Okay, perfect. So here's the first one of the drones. We've got 1 pink. Oh my God, 3 pink ones. Yep. They're all coming in. We've got 3 pink ones. I guess it makes sense why they've got partial loads, right? That one is 207. That was 291. That's 566. So between all of them, about 1,000 jugs. So blue just took off. That's pretty full. One of the pink ones just took off. That's pretty full. We got a pink one, should be landing immediately. And now it's kicking off. If we look... Oh, so we got that bug with the green ones here. If the drones that we're using for all the water happen to turn green, that would be very convenient. Okay, so we got another one coming on in. Great. See, this is looking a lot better already. Obviously, even with partial loads, that's kind of ideal. This guy's coming in with a full stack of 9. Full 9 stack. 1, 2, 3, 4, 5, 6, 7. He'd probably have to wait for 2 stacks to deplete before he can actually fully unload and then leave. And this whole time down here, we're looking at, I mean, I would imagine 100%. Yeah, 100% efficiency right here. This might be overkill, but this might be what we need. You know what I mean? 3 to 2. Basically 6 drones on the other side, handling 2 receiving ports just to be sure. Wow. Obviously, I'd want to let this run a little bit longer, but I'm going to assume that this is what we need. That we're going to need a full-on 6 ports per 2 water extractors for 2 receiving ports. So I think the final tally is going to be like this. We are going to have 6 drone ports for delivery per 2 extractors. We're going to have 2 receiving ports, and we're going to have 5 packagers unpackaging. And this is all per power plant. So that means that in total, we're going to have 6 times 15. That's going to be 90 drone ports on that end, on the water side. We're going to have 30 drone ports on this side. So we're going to have 120 drone ports handing off water. 120 drone ports handing off water. That's what we're doing. My God. Well, that's something. But most impressively, look at this. For the first time, we've got nuclear power. I think we've got quite a lot of work in front of us. Well, bunnies, thanks so much for hanging out with me through all this random shenanigans and testing. Honestly, I'm glad that we did it, because if we didn't, we're going to run into many issues, even if we design something that is, you know, good looking and stuff like that. If it doesn't run, it doesn't run. So we figured out a system. It's just a matter of implementing it now and actually figuring out how it's all laid out. So if you enjoyed the episode, please feel free to like, share, or comment down below. It helps us a great deal. I had a total blast. I hope you did as well. And I can't wait to get into the next one with you. Have a wonderful, wonderful night.